This is the second part of our series on business and supply chain strategies. In the first part, we learned that organizational strategy sets future goals, and supply chain strategy must align to serve customers and stay profitable. In this part, we will go deeper into organizational strategy.
Works in response to forecasts, it's called a push chain or push system, and it entails the following. In production, the production of items at required times based on a given schedule planned in advance. In material control, the issuing of material according to a given schedule or issuing material to a job order at its start time. In distribution, a system for replenishing field warehouse inventories where replenishment decision-making is centralized, usually at the manufacturing site or central supply facility. Everything in a push system is pushed downstream from one point to the next according to schedules based on the forecasts. The supplier delivers components in the amounts determined by the schedule to inventory, where they await use in manufacturing. The plant turns them into finished products and pushes the products to the distribution center or the retailer, where they await an order from downstream. The challenge in changing from forecast-driven, push, to demand-driven, pull, systems is in reducing inventory without also lowering customer satisfaction. When a demand-driven system is set up and managed properly, it can actually enhance customer service while reducing costs. But stockouts are a risk. As always with supply chains, the decision to switch to a demand-pull process trades one type of risk for another. In the forecast push process, the risk is related to the buildup of inventory all along the supply chain. Not only does inventory cost money while it sits in a retail stockroom, distribution center, or pre-production storage area, it runs the risk of becoming obsolete or irrelevant for a number of reasons. In a world of rapid innovation, inventory obsolescence is a very real threat. For example, Cisco Systems, for years an exemplar of successful and innovative supply chain management, had to dispose of US $2.25 billion worth of useless inventory when the dot-com bubble burst at the beginning of this millennium. All remainder tables are a sign of inventory overhang caused by failed forecasting. Magazine distributors used to destroy huge quantities of monthly magazines 12 times a year when they came back from retail outlets. Since magazines are inexpensive to produce and destroy compared to their retail price, the distributors would rather destroy 10 copies than miss one sale. Those are the results of producing to forecasts that no one trusts and purposely overstocking to be sure to meet unexpectedly high demand. In the demand pull, make-to-order model, on the other hand, the risk is that orders will begin to come in above capacity, and all along the supply chain, there will be expensive activity to run the plant over time, buy more and faster transportation, or sweet-talk customers into waiting for their orders to be filled or substituting a different product. Running short of stock is also a risk in the forecast-driven supply chain. Forecasts can be wrong in either direction. That's why the safety stock builds up at each point where orders come in. One technique to prepare for uncertain demand is kitting, which is preparing, making or purchasing components in advance, grouping them together in a kit, and having them available to assemble or complete when an order is placed. In Gartner's annual supply chain report, they rank the top 25 demand-driven supply chains, thereby underscoring the importance of this strategy. In fact, the companies that gain a position on this list have all applied demand-driven principles to coordinate supply, demand, and product management to better respond to market demand. If you would like additional information about this report, a link is provided in the online resource center. In reality, most organizations pursue a push-pull strategy, and the point where push moves to pull is the key strategic decision. Once that decision has been made, building a demand-driven enterprise can require significant changes in all supply chain processes. The following are some major steps. Provide access to real demand data along the supply chain for greater visibility of the end customer. The first requirement is to replace the forecasts with real data. The only supply chain partner with access to this data firsthand is the retailer, and retailers in the past have been no more willing to share business data than any other company. The other partners lack visibility. They simply cannot see what's going on with the end customer. But visibility is a necessity for building a pull system, and pioneers like Walmart have led the way in that regard. With point-of-sale scanning or RFID, a retailer can alert its suppliers to customer activity instantaneously. Instead of producing to the monthly forecast, manufacturers with that kind of immediate signal from the front lines can plan one day's production runs at the end of the preceding day. They produce just enough to replace the sold items. Establish trust and promote collaboration among supply chain partners. Collaboration is implied in the sharing of information, but more is at stake than simply sharing sales information. Partners may have to invest in new technology and develop new systems to be able to use the real-time data. With orders going out without a schedule, all processes will have to be altered: warehousing, storage no longer needed, packaging, shipping, and planning will all be handled differently in the new system. In return for receiving real-time data that allow reduction of inventory, suppliers and distributors have to agree to change their processes in whatever ways may be necessary to make the new system function without disrupting customer service. Increase agility of trade partners. Because the inventory buffers will not exist or will be much reduced in this demand-driven supply chain, the trade partners need to develop agility, the ability to respond to the variability in the flow of orders based on sales. The plant, for example, may have to undergo considerable change if it has to produce several different kinds of products under the new circumstances. When making to forecast, a plant can run a larger volume of each product to send to inventory. But when making to order, the plant may have to produce several different types of products in a day. There will be no room for long changeover times between runs of different products. Therefore, equipment, processes, work center layouts, staffing, or siting, or all of these things may have to change to create the capacity required to handle the new system. Strategy: product type driven. The last strategy we'll cover is based on a company having more than one supply chain, depending on the types of products that are passing along the chain and other variables. For a product with a complex bill of material, many parts that combine into many components to make the final product, a manufacturer may be bringing in materials from many suppliers. And these materials might range from low-priced commodities to fragile or sophisticated materials that require special shipping and handling. Suppliers might range from small specialized organizations to raw material giants larger than the manufacturer. Some are key accounts. Some might be occasional buyers. The finished products may be sold through several different channels: e-commerce, printed catalogs, commercial, and retail. These variables may combine in different ways, each suggesting its own type of supply chain strategy. In What is the right supply chain for your product?, Marshall L. Fisher distinguished two types of products, functional versus innovative, that require different supply chain strategies. Functional products are mature products that tend to have a low profit margin and a predictable demand. Functional products change little from year to year and have longer life cycles, perhaps more than 2 years, relatively low contribution margins, and little variety. Because demand for them is stable, they are fairly easy to forecast, with a margin of error of about 10%, very few stockouts, and no end-of-season markdowns. The appropriate supply chain for these products should emphasize predictability and low cost, with performance indicators such as high average utilization rate in manufacturing, minimal inventory with high inventory turns, short lead time consistent with low cost, suppliers chosen for cost and quality, product design that strives for maximum performance and minimal cost. However, make-to-order functional products, such as replacement parts for customized equipment, usually have long lead times, 6 months to a year. Innovative products have unpredictable demand, relatively short life cycles, 3 months for seasonal clothing, and high contribution margins of 20 to 60%. They may have millions of variants in each category, an average stockout rate from 10 to 40%, and end-of-season markdowns in the range of 10 to 25% of regular price. The margin of error on forecasts for innovative products is high, 40 to 100%, but the lead time to make them to order may be as low as 1 day and generally is no more than 2 weeks. The supply chain for innovative products should emphasize market responsiveness rather than physical efficiency, with performance indicators such as excess buffer capacity and significant buffer or safety stock of parts or finished items, aggressive reduction of lead times, suppliers chosen for speed, flexibility, and quality rather than cost, modular design that postpones differentiation as long as possible. Innovative products, with their high margins and unpredictable demand, justify the extra expense for holding costs. However, Fisher also proposes that manufacturers of innovative products can look for other solutions to the problem of unpredictable demand, such as aggressively reducing lead times and producing products to order rather than for inventory. Here is a conundrum. What happens when a product can fall into either category? Fisher says that some products can be either innovative or functional. Automobiles fit that description, with a low-priced, no-frills car like a base model Ford Fiesta or Hyundai Accent representing the functional end of the spectrum, and a Porsche representing the other end. Similarly, coffee can be functional, as anyone who has worked in an office knows, in which case it should be available quickly at a low price with perhaps cream and sugar as options. At a high-end coffee shop, on the other hand, patrons are willing to endure longer lead times and pay more money for their coffee, but they want variety in return. The idea that the same type of product can be either innovative or functional implies that one company might have more than one supply chain. And that's the contention of Jonathan Burns, a professor at MIT. Writing in the Harvard Business School's Working Knowledge, Burns asserts that one supply chain is not enough. 2, 3, or more would be preferable. One-size-fits-all supply chains may have been sufficient in the past when that was the competitive norm, but advancements in information technology makes it possible to have multiple dynamic supply chains that can accommodate different product and information flows. Burns breaks products into 3 categories: staples, seasonal products, and fashion products. Staples, which are much like Fisher's functional products, have steady year-round demand and low margins. White underwear is an example. Burns advises stocking staples only in retail outlets in small quantities and transporting them in truckload quantities. A full truckload, as you'll see in Module 2, is more cost-effective for the shipper than a partially loaded vehicle. Seasonal products could include outdoor patio furniture, holiday decor, etc., for which the demand is more predictable since it is tied to the holiday or season. Fashion products are like Fisher's innovative items, with unpredictable demand. Zara, the Spanish clothing manufacturer, has 2 supply chains, one for staples and the other for fashion clothing. To get the fastest response time, Zara uses European suppliers for the fashion items. But for the more predictable demand items, it uses Eastern European suppliers that have poor response time, not a concern, and lower cost. In addition to varying the supply chain by product type, Fisher recommends several other variables to consider: store type and time in season or product cycle. Demand varies considerably over the life cycle of many products. The same item might have infrequent demand built up at first, more stable demand in its maturity phase, and falling demand at the end of its life cycle. With more than one supply chain, the nucleus company can move its products from one chain to the other in response to changing variables, such as type of channel or life cycle stage.
Thank you for watching us. Please like, share, and subscribe the Expertise Station channel.